Hey guys, welcome back to Swat Studs. Today we are going to look at creating the Edgewear on HulkBuster shader. From here, we are going to create each imperfections like edgewear, scratches and dirt in separate shaders and layer it on top of the base shader using aiLayeredShader. So in this tutorial, I'll be explaining how to create edgewears using aiCurvature and how we can apply it on top of the base shader using aiLayeredShader. And I hope you all know what the edgewear imperfection is. When we use any object for a period of time, it will start to have these wearings, and most of the time it starts and more visible in the edges of the objects. So this is what we are going to create here today. So let's get into Maya and see how we can create this using aiCurvature node. And before starting with the edgewear, there is one more thing we have to add on the base shader before we go into our Edgewear shader. So that is creating the emissive part of the HulkBuster. So till now we have created all the other areas of the shaders, but the only thing we are now missing on the base shader is the emissive parts, which are coming on the knees, on the chest, on the backside and the hands. So for that also I am going to use the user data which we have already painted. So if I come to any of the parts which have the emissive part, and if I come to the mesh display and color set editor, you can see there are two masks which are painted here. So the first one is we are seeing here, which has the red, green and blue painted for the red, yellow and iron parts. And the second mask is for the emissive parts, where you can see it's completely black and only the parts which are emissive are painted in the white. And here you can see this one also has the mask, and on the back side you can see this part also has this RGB2_ mask. So let's see how we can create our emissive parts on the HulkBuster really quick. So for this, either you can create a new shader for the emissive part and layer it using an aiLayeredShader, or you can simply create it in the base shader itself using the emission attribute. So for this, I am going to add our AI user data mask on the emission weight, so that only those parts which are visible on the mask as white will get the emission on the base shader. So let's quickly create an AI user data color again. And this time the attribute will be RGB2_ mask. And let me just copy this name from our old mask and just add the RGB2 name on that. And I'm gonna copy the RGB2 name from the color set editor, and I'm gonna add it on the attribute. And then what I'm gonna do is I'm gonna just pick the out color R and I'm gonna connect it on the emission. So you can see now it's connected on the emission weight, and if I render our shader again, you can see the parts which are on white are getting that emission property on the base shader. So finally our base shader development is done now, and let's quickly start our edgewear. So from now on we are going to be using separate shaders for creating separate imperfections, and so we'll have to layer it on top of the base shader, just like we layer the base shader imperfections using a layer texture. So in Arnold there is a shader called aiLayeredShader for layering different shaders on top of each other. I'm going to create a layer shader here. So let's name it the HulkBuster layer material. And this is the layer shader is exactly like the layered texture. The only thing is on the inputs, instead of connecting textures, we connect shaders. So here also we can see we have a name option, enable button, and a mix. A mix is exactly like how it works on the layer texture. It just blends between two separate shaders. So either we can put it in in a value like between 0 and 1, or else we can connect a map to the mix to separate different shaders. So on the layer 1, I'm going to rename it as base, and I'm going to connect the base shader into the input. So in order to assign this new created shader to the HulkBuster, either we can select all the group and assign this HulkBuster material, or else the shading group is already assigned to all the geometries of the HulkBuster. So I can just replace this surface material from HulkBuster base material to a HulkBuster layered shader. And I can just delete the shading group which we have created with the layered shader. So both ways work. Now let's create a separate shader for the edgewares. So I'm again creating an AI standard surface shader for the edgewear, and I'm going to rename this shader to edgewear material. Either we can connect this onto the layer 2 here. So now we can enable layer 2 and rename it as edgewear and connect our edgewear material here. So in the mix of the layer 2, we are going to connect an AI curvature node. So before going into the Edgewear shader properties, let me just show you how the AI curvature works. So for that, I'm gonna quickly create a cube here, just to show you how the attributes of the AI curvature working. So I'm just creating some extrudes here, and I'm going to create a standard surface, and I'm going to assign this to the geometry. And let's just start rendering. Okay, for the time being, we'll just hide the HulkBuster, and I'm just gonna change the color to black. And now I'm gonna create a blend color. And I'm gonna assign this blend color into the color. And I'm gonna add the AI curvature red channel into the blender. So from the start, you can see how the object is coming. So now we can start looking at the attributes of the AI curvature. So the first one is output. Output defines on where the curvature node should calculate the edges of that particular geometry. So this is like ambient occlusion, or this uses ray tracing. So it only calculates on the render. So there is 3 types of outputs: convex, concave, and both. So convex and concave is like the lenses. The convex calculates only the edges which are going outside to the geometry, and which are like these outer edges. And the concave calculates the edges which goes inside of that object. And the samples are the samples which are calculated for the radius. So higher the samples are, the smoother or less noisy our curvature will be. And the radius is the radius on which the curvature will be calculated along the edges. So if we want to increase the width of the curvature on the edges, we can just increase the radius. So here now we can see with the convex, we are getting the curvature only on the outer edges or outer corners of that particular geometry. We are not seeing any inside edges getting calculated on the curvature. So if I change this output from convex to concave, now you can see now it's only calculating the inside corners of that particular object. So if you want both of them to be calculated on the render, you can select both. So it will calculate both the convex and concave. So I don't know why it's not showing. It's supposed to show. Must be some bugs. This is definitely some bugs which is happening on the Maya. Let me just go to another property, which is the spread. So the spread does what exactly the name signifies. It spreads the calculated curvature. So you can see with less values, the width is very smaller. And if we spread it, the width gets bigger and bigger. And the threshold is like if we give any particular value which is greater than 0, whatever information which has a pixel value less than that particular value will be avoided from calculation. So if I put, let's say 0.5, any value which is coming less than 0.5 will be removed from that calculated curvature. And the bias is the softness of the calculated curvature. So we can change these values according to our need, how we want to have these to be visible on our object. And the multiply just multiplies whatever we're getting with respect to the value we are giving. So if we give a value of 2, it will multiply the overall pixel values with the value of 2. That's pretty much all the attributes here. And the trace set is for when we want to calculate a curvature for multiple objects, but we want to avoid some objects from that particular curvature calculation. So if we come to the Arnold, there is space to add a trace set name here. So if we give any particular trace set name on a number of objects, and if we add that trace set name on the curvature, so it will search for any object which has that trace set name on its trace set attribute, and it will only calculate the curvature on any objects which has that particular trace set name. So, and the inclusive is for calculating that trace set. So if we enable the inclusive attribute, it will calculate the objects which have that trace set name and avoid all the other objects from the calculation. And if we turn off this inclusive attribute, then the opposite will happen, which is any object which doesn't have that trace set name will be calculated for the curvature. And self only calculates only the curvature which is getting from its own objects or corners. So if it has a, let's say, a floor beside this particular object, so you can see the floor is also getting calculated, or when the floor and the cube gets overlapped, it calculates the curvature which gets created with the floor. So that's pretty much all the attributes for the curvature node. And in this tutorial, we are not going to use any inclusive or trace sets here. We are only using these radius, spread, and threshold values for our tutorial. So let's delete all these unnecessary nodes and shaders, and let's bring back our HulkBuster. So I'm again creating an aiCurvature node, and I always use an AI range also with any nodes which are going to be used as mask, just to control their black and white values separately if I am limited to creating that values that I need with its inbuilt attributes. So I just make it a habit to create AI ranges in front of all the mask nodes that I create. So now let's just add this AI range red channel into our mask. So mix 2. And now let's see how our object is behaving. So if I isolate our aiCurvature, you can see the result is very low, and I'm pretty sure that these values won't make any difference on our shader. So we'll have to increase these values a bit So I'm going to increase the radius so that I'll get some values in here, and also I'm going to increase the samples to 6, so we will get rid of any noises which is happening while calculating the curvature. So I'm using the convex here because the bearings will going to be mostly happening on the outer corners of the HulkBuster more than the inner corners. So convex is the output we need to use, and let's go back and see how that object is coming. So now you can see we are getting the output we are looking for. So now, before going to further editing the curvature, we have to set the attributes of the Edgewear. So thinking it on a realistic way, let's say the whole HulkBuster was made with a single metal like these iron parts. It can be the same iron parts which were used to create all these yellow and red parts. But then after that, it was painted over with that particular metallic or dielectric paints or colors. So when an edge wear happens, when the paints get peeled off from the parts, the layer beneath it will get visible. So the layer which will be visible when edge wear happens will be these iron parts. So the Edgewear shader, which will be seen through these parts, will be the exact shader which is used for iron part. So what we have to do here is we'll have to put the same values which were used to create the iron parts of the base shader on the Edgewear also. So this is the same thing which is going to happen when a scratch happens. So through the scratches also, the shader which is going to get visible is the same iron shader. So we can use the Edgewear shader for scratches also. We just need to add a different mask, the scratch mask, on the third layer. So that will be covering on the next part of the tutorial. So now we are only focusing on the Edgewear here. And now let's just see what were all the values we were using on the iron parts on here. So the base color value was 0.35 and the metalness was 1 and the specular value was 0.4. We can create the same values here. The base color value was 0.35, our metalness was 1, and this the specular value was 0.4. So let's see how that value is coming here. So you can see before that it was really popping up like a white diffused shader. Now it's blending with the shader. Seems like there is no edge wearings happening. So let's just increase a little bit again on the aiCurvature, its radius. So let's just go with a value of 2. Let's see how it's coming now. So here, if we see it on the isolation, you can read its pixel values. We are using it as a mask, so the pixel values count. Only if it has a value of 1 on the pixels, it will show the Edgewear shader through the mask. So here we are not getting a value of 1 here. We are getting around 0.25, which is only 25%. So we need to increase our white value here. So I am increasing the multiply value to get a value of around 0.1. So again, just add 0.35. And yeah, we are getting around 0.8. So now you can see with the higher multiplication values, we are getting a good level of edge wears on overall the HulkBuster. So you can see now it's coming like a design on the HulkBuster, which will break in a few minutes. So yeah, I'll reduce the radius a bit because now it's going like a bit too high on all over. Let's just see how it's coming on other parts also. So on the knees, it is very less, but still we can work with that. All the other parts are coming really nice. Even the boots have a lot of really nice details from the Edgewear. So this is the base starting level of Edgewear which is happening. So as you can see, this is happening all over the shader, all over the edges. It doesn't have any breakups or variations. So it does make the shader overall look a bit surreal or it breaks the realism of the HulkBuster shader. So in order to bring back the realism, we'll have to break the edge wares. Like it doesn't happen similarly or equally on all over the edges. It has some breakups on somewhere on the edges, and somewhere it still maintains the paint. So for that, we are going to use fractals to break the curvature overall with again an additional AI layer RGBA. So in order to break the curvature overall, I'm going to create an AI layer RGBA shader, and I'm going to connect the aiCurvature AI range to the layer 1. Then I'm going to create a fractal, and again, for applying it as without the seams, I'm going to create a triplanar, and I'm going to add this onto the layer 2. So here I'm going to put the name as fractal big, because think about it. If I use a single fractal to break the curvature overall, the fractal is also a procedural pattern which will have a pattern which happens continuously. So it will again create a breakup which is happening all over the edge wares equally or similarly, which again will create a pattern which is visible through the breakup. So if I use different sizes of fractals to multiply it on top of the aiCurvature, it will break the curvature overall in different sizes, so that it will not look like it has an overall similarly broken pattern. So that's what I'm trying to create here. So let's just add this AI layer RGB into the mix, and let's rename it as Edgewear mix layer RGB. So let's see how the AI triplanar is coming overall on this one. So by default, it's a bit smaller. Let's bring back the size, and let's just put the operation into multiply. So now you can see there are some breakups happening overall on the edgewares, but this is still a very smaller breakups. What I want is a bigger breakups on the fractals. So I'll have to scale down this again. And now, in order to get rid of these smaller breakups, I can reduce the level max and ratio. Also, I can add an AI range in between the triplanar and the AI layer RGBA, and I can control the input min and max. So that I get the bigger breakups that I'm expecting from this. So if you see here now, this is what I was expecting from the bigger breakups. Like it's not similar all around the edges. We have some breakups on the edges and also some which maintains that paint values. So I'm getting a good amount of values here, but still I'll try to bring back some of that details again. So in all these parts, you can see it has a lot of beautiful breakups. It's not now it has a very irregular breakups happening all over the parts. So that is what I want, because these kind of breakups creates again realism. So now if you want, we can try to increase the radius a bit. Like, let's see if okay. Now let's create another set of hair range factor. Or we can just duplicate all these and let's just increase the scale. So I'm all again putting the operation to override. So let's see how that breakup is coming. So with that smaller breakups, the nicer details are all getting removed, and that's not what we want. We can change its, we can try changing its intensity a bit with the mix. So it's not necessary to add multiple breakup or procedural nodes to create breakups, but if you think it's necessary or it is needed some more breakups, you can use this option. So again, check the reference and go with it for further clarifications, or if you need more details or clarity on how much details you want on a particular node or attribute. So you can see it's a subtle detail. It doesn't make any difference or add any beauty to it, but still it's just the methods that I'm showing, like how we can add more and more breakups, or how we are not limited to a particular range of nodes, or how we can go further into the details and break it again and again so that it creates more and more realism. So here, maybe it's not visible that much on this particular shader, but if you are trying these methods on any other objects, maybe it works better on, or it's visible better on that particular object that you're working. So just keep in mind these things. So this is how we create edgewares on the shader. So in case if you need to add this kind of same, edgewares on the inner corners of the object, you can add the same shader onto the third layer and use the same curvature, change the output to concave and adjust some settings to your need, and then you can add some details onto the inner corners of the HulkBuster also. So on this tutorial, we are going to stop just with the outer corners edgeware imperfections, and now since we have finished our mask, let's continue building our Edgewear shader, because now we have just added some flat values here, but our base shader wasn't just about flat values. We were adding the layer, a fractal node on top of all the attributes to break it a bit. So the same thing we are going to do here for the Edgewear. So for that, I'm going to add an aiLayer RGBA. And finally, we're going to use the same bump also onto the Edgewear shader. So it won't be much visible with these kind of smaller parts, but still, just so that we are creating a shader which will be physically accurate. If we want to create a shader which will be physically accurate in all way, we'll have to create these kind of simple things. So we were using the same triplanar for the bump map. But here also we have one more thing we have to add, because whenever a paint goes off from a layer, there will be a bump on the edges, and the paint will be visible as a top layer, and the edgewear will be happening as a layer beneath the paint. So there will be a difference on the edges of the paint and the edgewear. So that also we'll have to create with our edgewear mix mask. So on the bump also we will have to create an aiLayer RGBA, and we'll add the triplanar of the bump, base shader bump, to aiLayer RGBA, and we will use the same mix value as the mix 3 has that value. So let's put the bump height to 1 and connect the mix 3 value to our mix 1. So the mix 3 is the base shader's iron bump mix value. So we are connecting the same iron bump mix value to our Edgewear shader. So let's just connect the R channel into the bump map. So I hope it makes sense when I am connecting all these layers from one to the other, because this is the exact same thing which we were doing from the part 1 itself. So I hope it's self-explanatory what I am doing and which nodes I am connecting to which nodes. Okay, we can't use this because it only affects on the iron parts, because the mask, it's a mask which is coming from the AI user data. So we'll just copy this output max value and put it in as mask, as the mix value. So that is 0.05. So now what we can do is, whatever value which is coming through the Edgewear mix should be darker than these bump values, so that whatever bump which is happening on the paint and the Edgewear values will be a little bit inner to compared to the paint bump. So that's the effect that we are going for. So let's just create an AI range for the Edgewear mix overall, and let's just connect this one to the mix 2. Or we can connect this value to the input 2, and let's just put this on subtract, so that whichever value we are adding on the layer 2 will get removed from the layer 1. And then we can adjust the value with the mix. So now it can go you can see the values goes to minus values now. So we can adjust the mix so that we are getting some positive values in here. So now you can see the values are getting darker. So let's see how the bump value is coming in here. As you can see, it's not a really visible It's just a really subtle difference, but as I said earlier, it may not be visible on this particular shader or this particular object, but in case you want to do another object in the future and you want to apply the same methods, if you want to create an edge difference with the layer 1 and 2, this is the method you should go for. Whatever bump values are showing on the layer 1, the bump values which will be on the layer beneath it should be darker, so that it creates that particular edge difference for the bump. So it may look more natural on that particular object. So let's create a final render now. And let's see how our Edgewear is looking overall. So as you can see, this is looking pretty nice with these Edgewears and all. So even we are going to add many more imperfections on top of it. So at the end, it will be looking better and better. So I hope this tutorial was helpful. One thing I'm emphasizing again to you is that you don't have to copy it exactly as it is for your workflow. Use this only when you think there is a need for it. Most of the time you can use a single nodes and get away with beautiful breakups. So at those times, be done with it. As you know, more nodes, more render time. So thank you for watching this video. Like this video if it was helpful. Share it with your friends who are interested in look development and procedural shading and texturing. Subscribe to this channel for more future contents. I'll see you soon with the next part. Till then, this is Swat signing off. Bye.